Hello, welcome to Game Development with Scratch. This is lesson 2. I guess to recap, let's go back to Scratch. So we basically went over the website as a whole. We went over what Scratch is, what you can do with it, what the Create button does, what the Explore button does, the Ideas button. We went a little bit into your profile, your stuff, the different projects that you can make. So for now, we're going to start actually working within the project space, creating your own project. That can be a game, that can be something, I don't know, music related if you want, basically anything you want. And we're going to help you get set up with that. So first, we're going to start with sprites, because sprites are very important. They're going to be your core objects that you use and change with your code during Scratch. So basically, sprites are the objects that you code. They're the objects that you change, the objects that you move around to make whatever program you're trying to make. You can see here when we create a new project, Scratch automatically gives us a orange cat to work with. You can see it's called Sprite 1. We can change that name to whatever you want. I guess I'll call it orange. I'll use an underscore cat. And for the X and Y values, think of the background, think of the screen as one big grid. And the coordinates 0, 0 are dead center, so right in the middle of the screen. If you're unfamiliar with graphs and coordinates, think of it as like, I guess let me pull up an image. Let me see here. Something like this. It looks just like this, right? 0, 0 is at your center, and as you go to the left, the X will decrease your X value. That's your X axis. That's your horizontal side to side. Your Y axis, your Y will be up and down. So as you go up, as you can see, as you go up, the Y will increase. As you go down, the Y will decrease. You can see that in real time. My cat is up here. It has a Y of 126. Drop down, negative 111. To the left, my X is negative 183. To the right, let me drag this over, 192. So you can see how that works. Size, obviously self-explanatory. If I increase it, the size will obviously increase. If I go down, the size will decrease, right? Let's go back to 100. All right, and let's put that back at 0, 0. Direction is obviously the direction it faces. Think of it as a bunch of angles, right? If I go 180, it's going to face downwards. Negative 90, it'll face to the left. 0 degrees or 0 direction, it'll face up. And let's say, for example, you're like, well, I don't want my cat upside down, but I want it to face left. How can I do that? Use this now. So now look at this. Boop. Now it's facing left. And it's not upside down. So that's very convenient. That's basically if you only want it facing one direction up and down wise, if that makes sense. Like, for example, this one, does a full 360 degrees. This one is just flipping, 180 side to side. This one, if you want no rotation at all, basically. You can create new sprites if you want. You can, this button here, that will upload something from your computer that you can use. Same thing with, backdrops and costumes. We'll get into that a little bit later. Surprise, that generates a random one for you. Paint, you can draw your own. If you choose a sprite or if you just click the button, Scratch has a library of many different sprites that they've already made. Like I can choose, for example, this dragon. It's already made for me. Let's make that a little bit smaller. We'll change the size. Let's go to 75. Much better. So backdrops, again, is basically the background. That's the like screen as a whole. I can change colors. Can I do this? Can I change colors like this? Never mind, I can't. Sorry. It has its own code. It has its own sound. It has its own backdrops that you can do with it. We won't be worrying about that for now. Now that we've covered sprites, we've covered over backdrops. Oh, I guess some quick thing to mention. You can see how at the bottom I'm like on the dragon. If I click on the orange cat, and now I'm on the orange cat, right? Each sprite has its own code. Each sprite has its own costumes, its own sounds, right, that affect it and it only. Okay, whatever code I have here will affect the dragon. It won't affect the cat unless I have it programmed to do so. So that's a good thing to keep in mind. So let's go to Orange Cat. Now, I've talked about costumes a little bit, so let's talk about what a costume is. Costumes are basically different versions of your sprite. You can see in this costume, it's like in a running position. If I toggle between it, if you look here on this screen as I toggle between the two costumes, it looks like the cat is walking, which is cool. They're different versions of the same sprite. So these two different costumes, as you look on the left side here, belong to this orange cat. They're not a different sprite, right? Even though it looks different, it's just a different image of it, different version, if that makes sense. Sounds, self-explanatory. These are the different sounds that you can have available for you to play for the sprite. Now let's get into the code. Okay, you might have seen these different colored blocks on the left side, and these are going to actually do the heavy lifting of running and doing whatever you want the sprite to do. So your blue motion blocks, these will affect the movement of your sprite. If you look at this screen, if I move it left, it obviously changes its X value. That is a part of the motion category, right? It'll go to different X values, meaning it'll go to different X and Y values. Basically, it'll go to different places on the screen. You can have it glide, you can have it point in certain directions, you can have it change its X, you can have it change its Y, you can have it move 10 steps. Your purple looks category, this is going to adjust how your sprite appears. You can have it, for example, look here, you can have it say hello. You can have it change colors. You can have it switch its costumes. That's where costumes is going to fall under, your looks. You can have it appear or disappear. If I don't want it to appear on the screen, I can hit hide. I can hit show. That's also what this is down here, hide and show. It's the same thing. Sound, obviously, what sounds will play. You can have music if you want. Events, this is going to dictate when to start running certain blocks. So I'll explain the green flag for a little bit. The green flag is basically your start button. Whenever you go to a person's program or game on Scratch or whatever, you're going to click the green flag. That's your start button. That's what's going to, start running the whole thing. So you're usually 9 times out of 10, actually 10 times out of 10 pretty much, because you're always going to have this, you're going to have one green flag clicked. So whenever the program starts, whenever they hit that button, which is basically the start button, that's going to kickstart all of your code. Control basically dictates the flow of blocks, what blocks run and do stuff, and what blocks don't. For example, I can have certain blocks wait 2 seconds or whatever before going to the next block. I can repeat blocks of code. I can have it go on forever. I can have blocks of code run only if a certain thing is true. If this is true, then run this code. And if it's not true, this else here, if blank then else, I can have code run if this thing is not true. Again, don't worry about that. I shouldn't have brought that up. I kind of opened up a can of worms with the whole if then else, if then. That's just if conditionals, but don't worry about that for now. Just basically know what control does, okay? It dictates the flow of blocks. Sensing. Sensing is basically the relativeness of sprites and objects, whether it's touching the mouse pointer, whether it's touching a certain color. You can have it ask the user, what's your name, right? And you can use that answer here. What key is being pressed? Basically, what's happening, I guess. What's happening and how you can use that is sensing, this light blue. Kind of hard to explain, but I think you get it. Again, and if you don't get it, you can look at each individual block, and it has, obviously it has words on it saying what it does. Operators. Operators is basically all of your math and your calculations. You can pick a random number. You can check whether a number is greater than or less than. You can, if you're a little bit more advanced and you know what Booleans are, these are your and, or not, right? Basically, like true or false. If this and this, then this, or one of those things is true. Again, opening a can of worms here, I'm sorry, but if you know what Booleans are, and if you're a little bit more advanced in code, then these are going to be your Booleans in Scratch. Don't worry about variables in my blocks for now. I will get into those later when we're a little bit more advanced and we've worked on our projects for a little bit more. So don't worry about those for now. Just worry about categories motion through operators. Those are going to be primarily what you're going to use throughout Scratch. Hope that clears up the large amounts of different kinds of blocks that you're going to see, but that's pretty much it. And if you have any questions, again, ask me in the Discord or look at the blocks yourselves. So, I guess let's start making some code. Let's get started. So, again, by the way, this is for the orange cat. So what code I write here will affect the orange cat. If I want to affect the dragon, click on the dragon, or I can click on them on the screen. Well, I guess not. Or double click. Or I can just click down here. So let's start with the orange cat. We're going to start with our green flag clicked because that's our start button. That'll kickstart everything. Let's say we want to move it. We're going to do 50 steps because 10 steps is really small and it's hard to notice. Looks, say hello for 2 seconds. We'll try and use a block from every category. Let's do start sound meow. Basically that'll play the sound meow once. Events, oh, we already have an event. Control, let's wait 3 seconds before going to the next block of code. Sensing, we can't really use the sensing. Okay, let me explain this real quick, sorry. You might have noticed this, but there's different shapes, right? Obviously, the shape of this, right, is your block. This connects to each other and runs in conjunction. These hexagons and these bubbles, these go inside of blocks, okay? You can see how this bubble can go inside of this weight bubble. It's kind of weird, right? I can plug this in. I can go boop, and it's now in. Instead of starting sound meow, I can start sound this. It's not going to work. It's going to give me an error, but yeah, you get how that works. Same thing with this. I can put this in if I need to. These are basically values that I can plug in inside the blocks. You notice how I can't connect them. I can't connect these bubbles or these hexagons to each other because they're not blocks. You put these inside of blocks. So we won't use sensing for now. Obviously, they have blocks inside of sensing, but I'm not going to use those. I can't either with operators. You can see it's all bubbles and hexagons. So we'll start off with this. This is a pretty good place to start. So let's click the green flag. You notice how it moved 50 steps, which is kind of a lot. Moved to the right. It said hello on the screen and it played the sound meow. The wait 3 seconds is kind of useless because you're waiting 3 seconds for nothing, so it just ends there. I'll put this up here so you can actually notice the 3 second wait. So let's run that again. Oh, another thing to notice, when I run this sprite won't go back to where it originally was. Okay, whatever you do to the sprite, it'll stay that way. So for example, if I'm in costume 1, if I switch it to costume 1, it'll stay in costume 1 until I put in some code to like switch the costume back. Okay, same thing with my movement. If I move the cat in my code up here, it's gonna stay there unless I move it back. Okay, you need to do that yourself, which is kind of annoying, but it's good. It gets you in a good habit. So for example, if I say, okay, I'm at x negative 157 and I'm at y 4, I need to remember that. I'm going to go over to the motion, and this is really nice because wherever you are, it'll plug that in for this block, this go to, okay? So now I have this block. For example, if I move over here, you can notice how that block now changes. So now, thank goodness that I have this block. So now I can save my original spot, okay? So you can see how I saved my spot, okay? If I didn't have that, then I would lose my spot unless I remembered the exact x and y coordinates. So let's say I'm starting my cat over here. Thank goodness I have this block because I can put that at the top and it'll automatically put me back in my original position. So let's click the green flag. You can notice how I go back to my original position. It moves 50 steps, waits 3 seconds, says hello, and then plays the meow sound. I think that's pretty much it as of now for what we need to know. This is just the basics of creating your program. You have your blocks, you have your sprites, you have your backdrops, your different costumes, which are your different versions, your sounds, etc. Let's name it. We'll call it first project. Okay. Don't worry about these buttons up here. Settings, language, and color mode. File, you can save it. Make sure to save it. Save as a copy just duplicates it. Load from your computer or save to your computer. Basically just accesses, like load from your computer, loads a project from your computer, saves it to your computer. Pretty self-explanatory. Don't worry about edit for now. Don't worry about share is if you want to put it to the public. See project page just puts it to the project page. This is where you can add your instructions or whatever. So that's pretty much it. Please join the Google Classroom. I'll add some review questions there, which will help. And if you have any other questions, just ask me in the Discord. I'll try and respond. That's pretty much it for this lesson. Thank you.